trying to align your development head with the development head of your dependencies. So eventually you would know at this time when it's merged, and it will be eventually released soon, that something is breaking. And it's and eventually you are developing with your own CI, so which is running with the stable. This you can set any head, any commit, anything which you want. So it's fully customizable in a few lines of, okay, some people doesn't like YAML. I find it useful because as it is rigid, you don't have too much freedom to make it wrong. So
yeah, basically, we give you the full-blown end-to-end CI so that project maintainers that are relying on PyTorch Lightning can rely on the fact that they will detect breaking changes as soon as they happen, so they have the time to interact with us, say, wow, why did you break this? And they don't have to wait for the release. And I think one of the values, and we need to apply the same strategy to Lightning apps right now. One of the values of an ecosystem is that when you bump into something, that something isn't broken. Because if something is broken, then you lose trust in the ecosystem itself. So our job is to expand the ecosystem while maintaining the quality of the ecosystem up. And this is the main driver behind creating the ecosystem CI.
Well, for me, it's a kind of two-way communication. So we may found out that some people are using something which we didn't expect it's exposed and they will really use it. So if we found that we break like half of our ecosystem, so we may reverse the change and discuss what are the proper way. And I think that Ethan had some recent experience with Flash and ecosystem CI.
Yeah, I used to have this thing where every time we did a Flash release, it would guarantee there was going to be a problem. And every time a Lightning release, guarantee there was going to be a problem because keeping the two things in sync was so hard. That 0.7 release that we spoke about, I think that was the first one where no problems, right? And the last couple of releases of Lightning haven't broken Flash. And the reason is I find out a month before that this is going to happen. I get a Slack message every day, every time it tests, and then I fix it.
Yeah, I think we've been pushing this to identify the main, many of the projects. The authors have been super grateful for this because I think it saves everyone time. So if you have a project that relies on PyTorch Lightning and you're not on this, please reach out. And then I want to mention tutorials, but before we do that, we are at the end of this, so do you guys have some questions on the roadmap, some particular interest that you want to bring up? Just come to the team whenever, but if you also want to ask something right now, it's the time to do it before we close. Nope, okay, so tutorials, just want to mention, there's, for example, again, on the theme of CI/CD, Jurka published this blog post that I encourage you, sorry, this, is it a repo or a blog post? I don't remember.
Yeah, it is a repository. And
yeah, exactly, it's a repo, yeah.
So what I found challenging is when people or researchers are sharing their notebooks, so it's very hard to reproduce. So you'd never know what was the proper order. Eventually, they just upload the notebook without the results. So you have a very hard time to know what was the configuration and so on. So this was the main motivation when we started with this one. So we encourage anyone to add a contribution. We also enforce some code standards because the contribution is added as a script, then you convert it to notebook, then execute it on a multi-GPU setting. So all the results are authentical. So I think that it would be also interesting for research or publishing results anywhere. That it was authentic results from the notebook. So whenever you download it, you also publish the specific versions. So it has to run anywhere, anytime.
Yeah, and also within labs, right?
Yeah.
If I think about labs, a lot of PhD students or master students working with their notebooks, the student goes, the notebook maybe was executed out of order the last time that somebody accessed it, impossible to reproduce. So I think this is a great thing to even adopt internally.
Well, maybe to that one, I will pass it to Thomas for his managing all class hosted on tutorials.
Oh yeah, so we had this great collaboration with the University of Amsterdam. So they actually built this amazing Lightning course in 10 notebooks, and we actually converted all those notebooks to tutorials. So they are currently hosted on the documentation, and everyone can learn about our best practices.
All right, so thanks to the PyTorch Lightning devs, and there are other devs in the room. So we had a representation here. So thanks to everyone, thanks to the community, and let's engage on GitHub issues and on Slack. And I hope this community keeps growing as healthy as possible. Okay, great. Thanks a lot. Now is the time for workshops.
this way because I already have Conda installed. I'm going to copy this command and create a virtual environment with Python 3.8. You can also use Python 3.9 or a newer version. And it looks like the internet is a bit slow. And yeah, so if you go to the zero setup folder, I put all the links into the readme.md file, and you can just basically follow this link, or you can also just go to lightning.ai. So is the internet working for everybody else? No? Slower, right? Yeah. That's not good. And on lightning.ai, you can go to docs and then Lightning Framework. But yeah, so if the internet does not work, we're not going to be able to do this tutorial, I think. Yeah, you can try to just copy this command directly if you have Conda installed, but it's not going to work because, yeah, the internet is too slow. Okay, so let me try this again. Apparently there's a different Wi-Fi access point here. So, okay, so that's good. So, okay, so in the worst case, I'm just going to demo it. If the internet is slow for everybody, we can't do it together, but I hope I can at least go through some steps and show you. So what I just did is I created a virtual environment, which we always do when we start with a new project. And then we're going to activate it using this command here. And my environment is just called Lightning. Okay, so now that I have this environment, what I can do next is I can install Lightning. So I install Lightning by pip install Lightning, very simple. Okay, so that's going to create that. Okay, once these dependencies are installed, we can quickly check if we have the Lightning command available. And yes, there it is. Lightning is installed. And then we're going to work with PyTorch Lightning and a couple of training scripts. So what we also want to do is install a bunch of other dependencies. So I have them listed here. You can copy paste this again from the README. So we're going to install PyTorch Lightning, Torch Vision, and all of that stuff. Okay. Okay, so we should all be set up now. And what we can do now is we can run our first app that I put into this setup folder. So let's just wait here. Okay, so that's finished. So what I have here is I have a test folder that already has an app. Let's just see if Lightning can run this app. So what we can do is we can do Lightning run app and then test / app.py. Okay, so our app.py file in this test folder contains a basic Lightning app that will print hello if everything works. So let's just see if everything is good. So what happened here is the Lightning app started and it opened my browser window and it just greeted me with this message: you're now ready for the next level. Okay, so this means I'm good to go with this tutorial. And it also printed hello here. Cool. Okay, so that means Lightning is working now locally. And if I want to run it in the cloud, I add -- cloud. So let's test that as well. As you can see, it's going to upload my code, the app.py file, to the cloud. And then it's going to open the browser and show me the logs for the app here. And it's going to install all the dependencies that are required to run this app. So we're going to wait until that's completed. And eventually, when the app is ready, we will see this button here, Open App, get activated. So let's wait for that to happen. We see that successfully launched. So yeah, okay, so the question was, where do we specify the cloud resource in this app? Well, I haven't showed you anything about this app. It's just, for now, it's a black box. But by default, we're just going to run on a free CPU. So every app is just going to run on a CPU machine for free. And if you want to use Lightning Work or anything that requires compute, you can specify that in the Lightning Work. And I'm going to show you also that in the code. So we call it Cloud Compute. So you specify that in every Lightning Work as an attribute, and you can say if you want a CPU, a GPU, multiple GPUs, and yeah, that's basically it. Yes. Okay, so let me try that again. So it looks like I ran that before. Let's see. Okay. So as you can see, it's maybe not big enough, but as you can see, it installed all the requirements here to run Lightning, and it's checking a bunch of packages. And eventually, the app at the end here says your app has started, and it says hello. And then we can also open the app here on the top right, and we see the same output as locally. Okay, so now that basically confirms that we can run the app in the cloud, and now we actually want to build an app ourselves, right? So let's head to the next section here. We're all set up. So the first app that we're going to build together is going to be an app that simply takes a training script that we already have and launches it. Okay, so all we want to do for now is take a training script that uses PyTorch Lightning, a trainer, and then build an app around that that launches that script in a Lightning work. And then, again, with a single command, we're just going to launch that in the cloud. Okay? So let's see how we can realize that. First of all, we need a training script. So I prepared that in a folder called project here. So what we're going to do in the command line here is we go back, and we're just going to copy this project folder into our first app folder. Okay. Now let's go into that app folder here. Okay. And let's look at the project files. Okay, so what we have here is a file called data module. Okay, so we have a data module that uses Cypher 10 as a data set. We have a requirement file that says we're going to use PyTorch Lightning and Torch Vision. And then we have a training script here, which is called train Cypher 10, with the Lightning module, with all the training step logic, and the data module that we instantiate here, and then eventually the trainer, and which is called trainer.fit. Okay, that's our basic PyTorch Lightning script. And now we want to build an app around that script. So what we will do is we will create a app.py file. So at the beginning, we will just import Lightning app and Lightning flow. And in order to launch our script, we're going to use a built-in component called popens Python script, which can just launch a new process and run our script. And eventually, we're also going to look at how we can build a Streamlit frontend around that. So every app is composed of a Lightning flow. So at the root, there's always a Lightning flow. So this is a simple class. We can name it whatever we want. And inside of that will be now the main logic. So what we need is a run method. Okay, so we're going to write the run method. And what we also need is a init. Okay. We're going to call super init. Okay. Then what we want to do is we want to add the component that will launch our script. Okay. So to add a component to an app, to a flow, we just add it as an attribute. And we use this one here, this built-in component, and we just assign it to the flow. And we are going to call it, for example, script runner. Okay? And what does this component take as input? It takes the script path as the only argument. And what's the path to our script? Well, we have it in a folder called project, and it's called train Cypher.py. Great. And now all we need to do, basically, in a very most minimal app that we could possibly think of is just run that other component. And every component has this run method, so we can call run, and that will launch that component, which here is a Lightning work, in a separate process. And in the cloud, that means potentially in a separate instance, in a separate machine. Okay? And we're not done yet. Every app needs to be instantiated as app, Lightning app, and then we give it the main flow. Okay? So the main flow is just the root component that has all the other children below it. Now, to launch an app, again, we're going to use the CLI. Okay? So let's switch to the command line. And let's check. So the app.py file is here. So we're going to run Lightning, run app.py. And for now, we're just going to run it locally to see if everything works as expected. Okay, so we got an error because I made a mistake. Let's see. Okay, so up, okay, that's good. So I added this to first app. Okay, 1 sec. So I'm in the wrong folder. Yeah, sorry about that. I was in the complete wrong folder, so yeah, that explains it. Okay, so I'm going to rerun that command. Just pretend that this didn't happen. Okay, so this is going to run our app. Of course, our browser is going to open, but there's no UI attached to the app, so it's just a blank screen. But what it should do now is launch the script. So let's see if that happens. Yeah, there you go. It just takes a while. I don't know why. So the script launches. As you can see, there are all these messages that we know from PyTorch Lightning. It's going to tell us, there's a GPU available or not, and it's going to print the model summary and everything. It's going to download the files for our data set, and then eventually it should start training here. So you can see the progress here. Okay, so great. We just wrote an app, a very basic app, that just launches a script. But now the magical thing is we can just run this app in the cloud, right? And our code and everything gets uploaded automatically. So here it finished, okay? So the script is finished, and I can just terminate the app by pressing Ctrl+C. So again, let's try to run this in the cloud because it's very simple. We can actually give it a name as well here. So let's call this first app 2, because I already have an app called first app. Great. So again, every time we launch an app, it's going to install all the dependencies. How does it know which dependencies it should install? Well, it knows because there is a requirements.txt file at the root of this project. Okay, so relative to the app.py file, if there is a requirements.txt file, then Lightning will know I need to install PyTorch Lightning, Torch Vision, and so on. Okay, so this is very important to be able to run in the cloud for Lightning to know what it needs to install. Okay, so we are going to wait a little bit here for that to happen. While we are waiting, are there any questions that you have? Yeah, please. You mean like a specific version or? Oh, so other build steps that you need to run before running. Yes, yes. So this is a bit of a more advanced topics, but yes, this is explained in the documentation. So this is called a build configuration, and you can attach a build configuration to any Lightning work you want, and there you can specify certain commands you want to run. So you can literally just put the string there, sudo install, sudo apt install whatever, right? If you need that, or make some binaries, compile something, whatever. And this will run before every Lightning work starts. Yeah, so this, let's just quickly go see in the docs, here. In Lightning docs, this is called the build configuration. Okay, so you find it here, and I think it's here, intermediate. What you can do is in your build configuration, you can return a list of commands you want to run, and then what you do in your Lightning work, you just attach that as your custom build configuration. So yeah, you can basically run any command you want on that machine because it's a Linux machine, and yeah, so it works as expected. Great question, yeah. So let's check back on our simple app here. Okay, so what we see here is now there are two components. There's the root component, and that's the Lightning flow that we defined first. And then there is the script runner. So this is the component, the Lightning work, that then launches the script. But remember, because it's a Lightning work, it's going to run in its own instance. And as I explained before, by default, that's just another CPU machine. So that CPU machine now needs to be set up. So it also needs to install the requirements, and that's what it's doing here. And we can actually go in the logs and see what this guy is doing. And it's downloading some dependencies here, and soon it should be ready and run the script. So let's see. While we wait, are there any other questions? Yeah, installing dependencies can take a while. Yeah.
Custom clusters. Is it possible to like use a simple Docker swarm as a custom cluster, or like running the works on our machines. Yeah.
BYOC, bring your own cluster, which means like enterprise customers can actually bring the whole Lightning cloud experience to their own cluster. So that's like an enterprise thing that's like developed right now and coming soon. Yeah, so that's definitely possible, and that's what we go for. But it's not available to the regular, non-enterprise user. Yes, yes. So what we see now here is the same output that we got locally. This Lightning work ran the script, so we can see that here. It's a bit small, but the script is currently extracting the data set that it downloaded, and eventually it will just start training. Great. But again, we don't yet have a UI. Okay, so it's blank. So let's quickly add that. Actually, adding a simple UI is not that difficult because, oh, and now we see it training here, perfect. So adding a simple UI is not that difficult because we have an integration called Streamlit, and Streamlit makes it very easy to get a simple UI with a bunch of buttons and text written in Python. So you don't need to write any HTML, CSS, all that stuff. You can do all of that in Python. So let's quickly add that. So in order to do that, we're going to define a new flow. Okay, so we call it user interface. It's going to be a Lightning flow because it will have to manage some state, and we will see what that state will be. Again, we're going to copy this init. Great. And again, we need a run. Actually, here we don't need a run method. But what we do need is a configure layout. So def configure layout. So what does configure layout do? It allows us to expose a user interface. So we're telling this flow attached to this flow is a UI, and we're going to point to what that UI is. So we're going to return a Streamlit frontend, and that Streamlit frontend takes a render function. Okay, and we're just going to define that function down here. And in that render function, now we can just write a bit of code. And what we're going to do is we're going to import Streamlit, and we're going to add a button. Let's add a button that starts our script, for example. So Streamlit as st. Streamlit has a simple button class, and we can give it a name or a text for the button. So we're going to call it run script. And now the question is, how can we trigger something in our app with that button? And the answer is with a state update. So everything that the flow manages is state. So if the state changes, the flow needs to adjust and rerun its run method. So what we do is simply access the state through the render function. So the render function, every time it runs, it gets the state of the flow that it belongs to. So in this case, the Streamlit frontend is part of the user interface flow. So if we define a state variable here, for example, self.run, self.should run, and we define it as false initially, now we can access that state variable here through this state parameter. So state.shouldRun. We can now assign that to the state of the button. And now every time this render function is getting executed, it's going to ask the button, are you pressed or not? And if yes, it's going to assign the value true to this state, which belongs to this user interface component. Now, we can use that user interface component in our main flow where we control running the script, right? So to add a component, again, we're just going to assign it to the flow. So we're going to call it UI. And doesn't take any parameters as input. And now this main Lightning flow has two children. It has a script runner, which is a Lightning work, and it has another flow as a child. And in our run method now, we can add conditional logic. So self.ui, if self.ui.shouldRun is true, we're going to run. Otherwise, we're going to do nothing, okay? Or wait. And remember what Luca said in the presentation about the event loop. This run method is going to keep being called multiple times a second, okay? And it's going to re-evaluate every time whether the button was pressed or not. And eventually, if I press the button and the state update, the state gets changed through the update, the next time the run method runs, it's going to pick up this change and going to run our script. So let's see if that works. So again, going to the command line, and let's just test it locally and see how it looks. Okay, so let's run that. And there you have it. This time, we don't see a blank page because we actually implemented a UI. And by default, the name here is just going to be the name that we gave that component. And here is our button. Let's see if it works. If we click the button, you can see there's no output on the UI because we haven't actually implemented that. But on the terminal, we see exactly the same thing as before. We see that the script gets launched. And that is because the state update in that UI has been propagated to the flow, and then the parent flow who accesses the state of the children can then react to these changes. Great. And yeah, the same is going to work in the cloud as well. But I want to move to the next section, but also give you the opportunity to ask some questions. So if you have any questions, please let me know. Yes, there's a question there. Oh, yeah, that's a great question, yes. Yeah, very interesting. Okay, so the question was essentially this. So if I run on the cloud like this, the app will have a name, okay? We saw that because we can give it a name. Let's say first app, okay? I'm going to run that. The app is going to finish, and it's done. And then I'm going to launch it again, but maybe I changed the code, right? When I run that again with the same name, what is going to happen is it's going to use the same machine that we used previously. Maybe is everything still installed there, right? It's going to launch faster. The answer is no. Every app that you launch is going to be a new version. So because the code changed, we need to reinstall everything, okay? And we don't really know which machine you get, right? You just get the next available machine. So maybe the one that you previously used is already being taken by someone else. So in the cloud, it just doesn't matter, right? So you just get whatever machine is available. But you can force also the app not to be another version. You can just give it another name. And then you essentially make a copy of that app. And now it's not a new version, it's just going to be a completely different app. And you see that if you go to your apps, so if you go to apps and components, my apps, you see the list of all your apps, right? And here are all the names of the apps. And if I were to upload a new version of this app here, it's going to just overwrite the existing one. Internally, it's going to create a new version. But I can give my names whatever, my apps, I can clone every app that I have as often as I want. Yeah, so that's basically it. Any other questions? Yeah, again, you? Yeah. Yeah, so the app runs forever, yeah, in theory, because of this infinite loop that runs, right? So if you don't actively terminate the app programmatically or externally, the app is just going to run forever because it's going to wait for state updates, right? So this run method here is going to keep being called. If there are no state changes, fine, nothing happens. But there may be state changes that come through the UI, right? So we need to infinitely keep looping and running and waiting for state changes. So yes, an app will run forever. If you kill it, then all the resources will be cleared and the machine gets taken away, and that's basically also the end of when it's going to, what it's going to cost you, right? So you only pay for the amount of time the app runs. Of course, if you use the free CPU, then it's not going to cost you anything. Yeah, so that's it. Any more questions? Yeah. Yeah, so, okay, so I think your question was, what happens if one component is going to write to another component at the same time as another component? So basically, can there be a race condition? Not really, because the only things that can run in parallel are Lightning work. We haven't actually shown that yet, but the only things that can run in parallel are Lightning work. And when the Lightning work run in parallel, they are first of all isolated from each other. And remember, in the presentation, Luca said that Lightning work has to be a leaf. That means it can't have any children. So essentially, a Lightning work can't really access any other components, so any other flows or works. So that eliminates that possibility that there can be some contradictions, right? The only components that can access other components are flows, because flows can have children. But in the flow, things are always going to run sequentially, right? Except, again, Lightning works. But if things run sequentially, then there can be no such collision. So, yeah, so that's the long answer. Yeah, sorry, the answer is no. Yes, cool. Yes, wow, many questions, I love it.
How would you generalize this script to scan
Training many different what? Oh, yeah. Actually, I think this question can be answered by the talk or the second part of this this workshop. Sorry. So what you can do is you can launch as many Lightning works as you want, and for each of these Lightning works, you can parameterize whatever you want. So the cool thing is that every Lightning work can run in parallel. So if you give a work the parameter parallel equals true, okay, and let's say here we're going to call another script, let's say, then when you call the first one and the second one down here, okay, oops, 1 and 2, now they are going to run in parallel, right? So when we hit this line, we're going to run it, and then we go to the next one. So that basically means you can implement hyperparameter optimization in just a few lines of code if you just make a list of these works and launch it that way. And yeah, that's actually what Thomas will show us in the next section. Awesome. Oh, there's a question there. Yes? Yes, okay, so the question was, why did I make a separate flow here and not just move this upstairs here? So why did I not do that? Yes, so that is currently not supported, but yeah, so I think that's going to be possible in the future, yeah. That's what we want to add, because the root flow can define such a layout the same way as any other component. So yeah, that should actually work. Yes. Here I guess I just wanted to demonstrate a second component. Yeah. So yes. But yeah, every Lightning flow can have this configured layout. Yeah, so that's basically it. Now, I want to move on because I want to show you something really cool. So what we've tried to build here is a PyTorch Lightning app of some sort, right? Something that can run a script, and we don't actually have to change anything inside of the script to make an app out of it. And we've built on top of that app by just adding other components, right? We added the UI, and then through the question here, we added even multiple script runners that run different configurations, right? And what we've done, we've actually built a template for you, so you don't have to write all of that stuff for your training script. And this app that I want to show you is called the PyTorch Lightning app, because with a single CLI command, you can generate an app from your script, from your project, and basically generate all this code that we've written here, except that it has a lot more features built in. So let's have a look at that. Okay, so this is this second folder here, and so let's quickly go to the terminal and change the folder to PyTorch Lightning app. Okay. Yes. Okay. Okay. So just let me just clear things up. So this is what you will see when you look at that folder. Now, again, we want to copy the project folder with all of our scripts and data modules and Lightning modules to the project folder. So the app folder that we are going to use here. Okay, so we have our project folder here. Again, it contains all our scripts. And then what we do is simply we call Lightning init pl app. So the CLI has an init command, which allows us to create new apps or app templates. And then what follows is the name of the template. So in our case, that's a PyTorch Lightning app. And then an argument that this command takes, or this template takes, is the path to the script. So our script was in project, and then it was called train, let's say CFAR. Okay, so that's all we need to do. Let's see if that works. It's going to copy that script, that project folder, and wrap a new project around it, which is going to hold the entire app. So what it did is it generated some folders here. It generated a folder called core, which holds some of the components in the app. It created a folder source, which contains all the source code. So it literally just copied the project folder over into that. So then we have some basic tests around here. So your app is already tested, and you can add new tests, of course. We have the UI. So this app has a UI, and inside of that folder, we have a React UI built for you. Then we have the app.py that we can run, and just also a setup.py so that you can install that app in your environment. And then what it gives us is this command here that we can run. So the app is already ready to run, and this is how it looks like. Okay, so here we see the name of our script that we can launch. We have a start button here, we have some information here, and if we click start, we get a pop-up here with a launch configuration. Locally, we can't really select the hardware, but we will see when we launch it in the cloud, we would be able to select the instance type here. If our script has arguments, we can pass it in here, or also through the command line, and also environment variables if we want to specify that either here in the UI or in the command line. But for now, we're going to use the default values and launch it. And it's going to start locally. Again, in the background, we see that in the logs, the app starts and starts training. And in the UI, we see a live update of what our trainer is doing. And because we assume here that the script is a PyTorch Lightning script, we actually get a lot of free information out of this, because we know how to hook into the trainer and get all the progress out of it. So we can generate these nice progress bars. We can get the total progress, the stage at which it is in. So you see that since we only trained one epoch, it immediately went to the testing stage. We can also hook into the trainer and collect all the hyperparameters. So if we look at the model here, apparently this has a parameter for the learning rate and a batch size. And if we look at the trainer parameters here, we see all the options that are set. So this is kind of like in the style of an experiment manager. So if you look at max epochs, for example, we see that we trained for one epoch. And if for some reason your script has an error, the app needs to handle that. So we don't want that the app crashes if your script is bad, right? If your script has an error, then the app will handle that. Essentially, the Lightning work that runs the script will fail, but then the flow can catch that error and tell the UI, display that error in the UI. And that's what you would see here in this error window. But what we also get, which is really cool, is we get training logs here. So because we have insight into the trainer and can basically look up what logger it is using, we can also launch a corresponding component for that specific logger. So if the trainer is using a TensorBoard logger configured in the script itself, right, we can just ask the trainer, hey, which logger are you using? If it's TensorBoard, we're going to launch TensorBoard. How do we launch TensorBoard? We launch it into a separate work, because the TensorBoard if you've ever used TensorBoard, you know you need to start a server, right? You need to type into the terminal TensorBoard minus log directory, point to the log directory, and it's going to start that TensorBoard server. But we can now automate that, right? You don't have to do that anymore. With the TensorBoard component that we have inside of the training app, it's going to do that automatically for you. And if you switch, if your script has a different logger, for example, weights and biases, it's going to detect that and show the weights and biases user interface here. So you just don't care anymore about setting these things up. It's just all in one app. And that's the main motivation of this PyTorch Lightning app. It's going to give you all these components and these features built into an app. But most importantly, it's like a template so that you can go in and modify it to your liking. So you can remove components or add components to it to really fine-tune to your workflow. Yeah, it's going to give you access to all the features of Lightning itself, including also running it in the cloud. So let's try to do that. Let's actually see if all this works in the cloud. And you guessed it again, we do -- cloud, and because I already had one running, I'm going to name it PL app 3. Okay. So again, it's going to upload all the code, including our entire folder with the source code, including all the app files. And let's see if that works. So again, in the meantime, while this is installing all the dependencies, are there any burning questions about the app? Yes? If the root flow goes down, what happens to the state? Yeah, so the root flow can go down, if there is an error. So if your app has a crash, the root flow will go down, and essentially the cloud backend will detect that and just kill essentially all your running children. So all the other flows and also the Lightning works. Because if your root flow dies and we can't recover it, then there's no point in keep running the other works, because they won't be able to send state updates back, and they won't be able to communicate through the state with other components, so there's no point in running them. But with that being said, the app framework has essentially fault tolerance built in. And so if your app fails, we are able to capture the entire state and essentially restart your app and plug that state back in, right? So it's not currently available, but this is coming in the future versions of Lightning, right? So this is like one of the core ideas about the framework, is like the state, and that the state can be captured and saved. And just like a checkpoint in a PyTorch model, you can start the app back up and reload that state, right? And that allows you to essentially continue exactly where you left off. And so that's the story there, the long answer there. Yeah, great question, yes. So now we actually see that something started here. So the open button is available. So let's see if it runs. Yeah, so there it is. That's the same thing we saw locally. We can start, and now we also see the options here that we have available in the cloud. So we have 2 CPU machines, a smaller one, one with more CPU cores, and then a small GPU, a single GPU, a very fast V100 GPU, and then also a multi-GPU machine. Awesome, so just for the sake of this, we're going to run with the CPU machine. And as you can see, locally, the app basically immediately started training because, well, locally we can just run the script, right? But here, actually, we need to wait for the work to start up, right? Because this is now in the cloud. It needs to actually grab another machine first. So we see that here now. Previously, we just had the root flow running. But now, because we pressed start, we actually have the script runner running here and installing the dependencies and getting set up, getting provisioned, right? So if we browse the logs and go to the script runner, we see exactly what it's doing. It's going to set up the requirements. And it's actually going to pick up the requirements that we specified in the project. Again, because this is a template app, it needs to completely wrap the script and the project we are running with, right? So if it takes all the source files from your PyTorch Lightning project, it also needs to take the requirements from there. So if you have a requirements file there, it will load these requirements into the work that runs here and installs everything that's necessary to run your project there. So I think that's really powerful. And here we see it just installed PyTorch Lightning. And there you go. So the logs tell us now it started running. And if we go back to the app, yeah, so it started to track the progress here. And soon it's going to update. Let's see. Slow. Yeah, there you go. So and it updates. And again, as we saw earlier, locally we can just browse the logs here. So if you go to the log tab, we see that it's spinning. So we're waiting on something. What are we waiting for? Well, because we just launched the script, right? We now know what the logger is, what we're using, right? We just launched the script, so the trainer just informed us about what logger is used, but now we have to run another work that launches this TensorBoard logger. Why? And we see that here. So this is the logger component. Why would we now run an entirely different machine just to display TensorBoard? Well, maybe our script runner is eventually going to finish, right? And maybe it's running on a very expensive GPU machine, right? And if we were to run the TensorBoard server on that same machine, we would have to keep that expensive machine up just to serve these logs, right? Even though the training finished. So that's why we actually want to run the TensorBoard in a separate machine that runs on a cheap CPU, right? So that even when our script runner finishes and it's going to release all the resources, we can continue running the TensorBoard server basically on the free CPU and see our logs after the training has long finished, right? So this is kind of how you want to build your apps. You want to build them in such a way that you get the most out of these Lightning work abstractions, that each can have their own compute, and you want to make use of that. That's what we do here. And we also use this storage feature in Lightning to synchronize the logs from one work to another, right? So this is another very important concept, because the app is distributed and different parts of the program are going to execute in different machines. It means if we want to access files in one part of the app, in another work, we need to transfer the files between machines, right? And that needs to go over, well, the network somehow, right? And that's where we make use of this storage abstraction in Lightning. Great. So this is the PyTorch Lightning app. Again, it's very simple to use. I'm going to show it again. So the command that we used was lightning init pl app. So lightning init means we're going to initialize a new template. The name of the template was the PyTorch Lightning app. And then we point to the script we want to be captured, or the project we want to be captured by that app. So I encourage you to try this out with your own projects. So, and then run it in the cloud. And yeah, so again, I'm going to open it for questions. So if you have any questions, please let me know. Yes? The debugger in a local app. Yeah, you can use the regular, so excuse me, the question was, can we use the debugger in a app running locally? So yes, I mean, you can set breakpoints wherever you want. So if you just set a breakpoint using like this, so simply, let's see, so in our first app that we had here, if we wanted to set the breakpoint here, we would just write breakpoint, right? Or import pdb pdb.setTrace, right? And run the app, run the debugger this way. And yeah, so. Thank you. Yeah, feel free to ask a question. I think your question was, can I also set the breakpoint inside of the Lightning work, right, in the Python script? Yes, in this case, yeah, so that's actually a bit difficult. I think that doesn't really work because every Lightning work runs into its own sub-process, right? So it's a bit difficult there, but I think we can provide some tools in the future to make the debugging easier there. It's a bit tricky because, again, everything runs into its own process, into its own machine. But yeah, obviously we do that to leverage the power of distributed apps. So in a way, it's a little bit like debugging DDP in PyTorch Lightning. You know that debugging distributed models is a bit difficult, right? So it's similar here, right? But the good thing is that because the app framework is so modular, you can essentially always like isolate your Lightning work into essentially your own app and debug it this way, right? And then in the end, you just plug everything back together. And in this case, you would then debug the flow, essentially. And because the flow is running in the main process from which you launch your CLI, you can always debug and set breakpoints there, no problem. So that's the easiest part. Yes. Okay, so yeah. So now I think we need to take a break, a 15-minute break. After that, we will return. I will show you how we can extend our app with multi-node capabilities, so managing multiple works to train together. And then again, after that, I will hand over to Thomas, who will introduce you to the hyperparameter optimization. So yeah, feel free to ask more questions in the break, and thank you for attending the workshop. So.
Well, this seems a lot nicer.
Yeah, but I'm a bit frustrated.
Every single person was.
And if it doesn't?
Tomas. Tomas. Toma. Can't hear me? Toma. Tomas. Tomas. Good. All right, everyone. Real quick announcement. So we will. Hey, everyone. Quick announcement. We will be continuing, Adrian will be continuing his session here, as well as then Tomas looking at the supercharging your training session. There will be another workshop going on that will be covering a whole host of different apps at a higher level. In the other room, if you are interested, you're welcome to stay or to migrate over there. That, I will say, is less of a really hands-on keyboard type of experience, more just getting a cursory introduction versus what you've been doing here. So open invitation over on that side. We'll be getting started in just a few minutes. And with that, Adrian, you're ready for me to turn it back over to you?
Thank you so much.
sheer magnetism is going to drag you towards me over the course of the presentation. Mansi, with the video app. Yep. Okay. What? Okay. You ready to go? Okay. So over the next 45 minutes, we're going to do a kind of high-level overview of 3 apps. I'm going to do Flashy. I think Mansi over there is going to do the video app, and then Eric's going to do Hacker News, right? We're not going to do any code or anything like that. We're just going to show you how we would run the app, go through it. Please feel free to follow along. You know, if you want to, go on the website and click with us. That should all be fine. And if we get time, we'll go into maybe a little bit about how the code is arranged, but not really what it's, you know, we're not going to get into actual lines of code, but maybe the structure and what the components are. So this is the app page in the gallery. When you go to the gallery, you find all of the apps that we have in Lightning AI, and in there you can click on any one, and you get the README, and you get the clone button. And you can see some information about your app and who the authors are and the licenses and stuff like that. And so the first thing you want to do whenever you come across an app is, if you can view it, you're going to view it with the launch button. We can't do that for this one. But what we can do is clone and run. So if we hit clone and run, that's going to launch our app. Flashy, as we kind of mentioned earlier, and I think it was presented at some point, it's an AutoML app. What that really means is we're going to have some configuration. This is my data. This is the problem I want to solve. And then once we've done that configuration, we're going to run some hyperparameter optimization, right? In the background, we're going to make a bunch of possible choices and see which one's best, right? Automatically, hence the name. And it's built on top of Lightning Flash, which is our applied ML framework. So that's what's driving the ML part of this. And that's where a lot of our configuration comes from. As we start up, we can see our components. We can see what type of component they are. And we can see what state they're in. And we can see their logs as they're building. In Flashy here, we have the root flow. All apps have a kind of root flow. Our UI for this is all React. So we have one front-end component that is our React UI. And we have these two servers which are going to do file management for us. One of the challenges that's kind of unique to this style of app is that we have to move data around. I have to upload data, I have to download checkpoints, I have to be able to wrangle files, which means I need file servers. And so those works when they run a Flask server, and that Flask server lets us have and deal with files. And we can see they're still building, and eventually, when they're ready, we can open our app. But this is where you, as an app developer, are going to live, right? This is going to show you all of the information you need to know about your app. This is the admin view. And this is where you're going to debug it on the cloud if you need to do that. And get access to your logs and whatever else you need. And so in theory, if we scroll up and then hit Open App, so we could also stop it and other stuff, but we're not going to do that. We're just going to hit Open App, and we should get a UI. And so the UI, this is our React thing. This is all one big React UI. From here, we can configure everything. We can configure our data at the top and our task. And eventually, we're going to configure our kind of AutoML sweep and hit run and train some stuff and whatever. So we might as well do an example. So if we can leave it with image classification, that's relatively standard. We can use a URL, and if my glamorous assistant could copy that URL into the box, and hopefully, as long as our file servers have started, this will work, and then hit upload. And so now that's ready. We need to tell Flashy something about the format of our data. It's folders, that's fine, so we can leave that. Where's the train data? So if we click there, that will give us the list of possible folders. We want Hymenoptera data / train. Yep, that one. And then we need some validation data, so we know if we've done any good, especially in a sweep. So we can use Hymenoptera data / val at the top there. And now we need to do some configuration about our model. What we wanted to do with this was really take away as much of the domain knowledge as we could, right? We wanted to make it as easy to make the decisions that get you the results as possible. And the model we came up with was you can choose the kind of strength of your model, right? Demo model, or if you click on that, there's like a regular type of model, or you can have SOTA models. And we also wanted you to choose the target performance. Technically, what that's doing is deciding how many different hyperparameter choices we're going to make, how many different runs we're going to do. But practically, what it's doing is the more runs we do, the better our results are going to be. So it's the performance. If we click on the performance drop-down and go for medium, on the right, yep, and then we can start training. And now we're in the results view. This is going to show us each of these rows is a work, which means each of these rows is a machine in the cloud. They don't collide with each other. They're all their own instance. And they're now building. And they've got different hyperparameters, different backbones, different learning rates. And what you've seen in the demo, I probably won't wait for all this to start and run, but you've seen it in the videos and whatnot earlier, is that when this eventually finishes, we're going to get performances and we're going to be able to download checkpoints in the more buttons on the right-hand side. That's the app, right? That's it. It's quite simple, but effective and cute. So, where do we go from here? If you've run this, it's worth pointing out that Lightning apps are all public. This URL is public. You can tweet it. You can hashtag the Wi-Fi password and maybe win a thing. But we can also look at the code. So if you scroll up, and, oh no, okay, maybe we need to open a new tab and go on to lightning.ai again. Okay, and then if we go apps and components and find Flashy again through the UI. Other one, app gallery. Yep, perfect. And then that one. And then if we click on the GitHub repo, so from here, you've got all this metadata, so we can look at the code, right? We can go onto GitHub and see it, it's open source. That's the other thing about a lot of these apps as well, is like if you want something different or you think there's a new thing that would be really cool, open an issue, open a PR, like it's all open source, that's part of the magic. But if we click on Flashy there, that's the kind of main directory where all our components live. And we can just have a little peek at the organization, right? Each of these files, like run scheduler, HPO manager, these are Lightning components. Run scheduler is a flow that's going to kick off all our runs, right? When I'm ready to run, I call into run scheduler and that makes all my works. HPO manager is a flow that's going to tell me what parameters I need to use for each of those works. And then in the components folder, that's where all our kind of engine lives. That's things like the file servers, and eventually we have Gradio servers that we can launch, and we can launch 51 and stuff like that. These are all components, and we're also in the process, you'll have seen in the components gallery, there are components called Flash 51 and Flash Gradio and whatever. These are those taken out and made a bit more general, made a bit more flexible, and launched as their own components. And that's really it, right? Like, it's not super complicated. It's mostly UI at this point. It's, and what it does is trigger a bunch of runs and let us download checkpoints. That's the simplest possible. And it's going to get gradually more complicated as we go through video next, and then eventually Hacker News. So I'll leave my time.
Hi, hello. Yeah, here we go. All right. So, hi everyone. Name is Mansi, and I'm an engineer at Lightning team. And today we will show the InVideo search app. I hope it will be fun. We will build the app. And yeah, let's get started. I hope you are enjoying the DevCon so far. Yeah, welcome. So just briefly, what we are going to show today, we will just have an idea what's like the traditional web app versus a Lightning app. And we will show the demo of the video, and we will, hopefully, we wanted to build the app, all of us, and we will explore what we can do more with Lightning. So yeah, as Luca mentioned in the morning, the building blocks for a Lightning app is mainly a flow and a work. This is just like a recap. The flow is mainly for like coordination and orchestration if you want to manage like many processes, like if you want to manage a workflow. And the work is for heavy lifting. If you want to make a training pipeline, if you want to make something that takes long time, and so you will put it in a work. So the traditional app, or like if you view the Lightning app, it would be something like this. You have the root flow on the top, and then you have multiple flows, and then in the leaves will be work that they are doing some work that it will be work for a long time, that will be running for a long time, not only like dying quickly. But the traditional web app, like the classic web app, is something like this. You have a front end that runs in a web browser, and you have a back end, and then you might have like a model serving API to serve your model, and then you have a database. And yeah, you use like communication between HTTP requests all the time. This is like the very simple web app example. But we didn't mention anything like flow and work all this way. So how we are building Lightning apps without mentioning what's like front end and back end, how we will integrate how we can build your app, whatever it is, into a Lightning app. So if we actually think about, if we look at the flow and the work, we mentioned that the flow is for orchestration, and the flow also can serve a UI. And the work can do any long-running jobs, or any like jobs that takes long time. It can be a training pipeline, it can be an API server, it can be a database, it can be anything. It can be like for model serving. You can use a work to run an API server to serve a model. And that's what we do in the video app. So an example to run a web server, like a fast API, locally or anywhere, it's something like this. Just like few lines of code, and then you have the server runs. And if you want to run it inside Lightning work, it's basically the same. You just put the start server inside the run method. And that's it. You can run any server you have. You can run a database, you can run a work, you can run an API, you can run Flask, you can run basically anything inside a work. And yeah, that's that easy. So we will show the demo now of the app. So that's what we built. That's the basic architecture that we used. We used a flow to display the UI and a work in the back end to serve to serve the model that we have for the InVideo search. So the InVideo search app, it allows you, it's a very basic app, to search inside YouTube videos. If we can open this link in the top. All right. Yeah, here we go. So this is like very simple UI. It's built in React, and if we take one of the examples in YouTube URLs and put it here, and then press enter, so wow. So what we will do, what happens now is we have our server runs a Flask API, and we send this video to the server, and the server gets processed. And then in the end, we will just like search anything in this video. I wanted to show like what's actually the video, and then we can try to find something. Like if you give me an example, what do you want to search in this video? Maybe not this one, maybe the other video, but it's all fine. Yeah, let's take this classic baby driver. So yeah, we will exit, and yeah, put the link again. Yeah, here we go. So we can search for what? Do you have any ideas? Red cars? Yeah, red cars. Okay, next. So what this app is doing, so we are using a simple clip model that, yeah, just reads the video, process everything, trying to match the search query with yeah, the video features like that we processed. Another example, headphones. Let's search for headphones. Yeah, we can cancel, sorry, yeah, you can just write headphones. If anyone has a video in mind, we can try any video you have, but it's just like 5 minutes because our server is a little bit limited. Yeah, this is headphones, yeah. What else? Sorry? Man laughing, okay. That's good. This video does not anyone, no one laughs in this video. Just like send any video like less than 5 minutes maybe to process faster, yeah. Seat belt? Actually, I wouldn't get this one, it's very far. Yeah, and if we click, it will just open the YouTube URL that where exactly this was found. Yeah, so I wanted to have a look in the architecture, how actually this work in the code behind the scenes. So yeah, if we get back to the slides, you can actually, if you open a Lightning website, lightning.ai website, you will find all these videos. You'll find all these applications. You can try it yourself, like if you go to the Lightning AI and open the in-video search and launch the app, you will be able to run the app without even cloning, without having your own private instance. But if you want to run your own version of the app, you can, yeah, click clone and run. If we also look at the code, like if we open, yeah, that's fine, never mind. Yeah, but this is just an image. So if we open the website, lightning.ai, and okay, that's fine. No. Actually, yeah, we can just move on to generate some ideas. Let's get back to the slides. What we wanted to do is we wanted everyone to have a look at the code. So if you are on laptop, you can feel free to clone this repo or write lightning install app video search, and you will have the app runs locally, and yeah, you can clone this branch and see how actually you can make a work runs any API server. So this is very simple app, but in reality, if you want to build a complex app like Flashy, it's more complex. This is just, you can build everything inside Lightning app. So if you think about it, you will have also like a root flow, And then if your app like needs an APIs, which is I assume maybe if you need Redis, if you need a database, everything can be a separate work. And what the beauty of this is you don't need to build everything all the time. All this component, like all this block, can be a component that it's built by someone else, and you can just use integrate it in your app. The same is like, the same is like if you have like a training module, you can separate it and share it with the community. And yeah, all of this can be an app and can be just like Lightning app that it's looks great. So basically there is no limit of what you can do. It's just the way you want to build your app. Yeah, what else? So one of the nice components, if you want to, as an example, is the Lightning Serve component. If you go to Lightning AI and check the Lightning Serve, this component allows you to serve any machine learning model. And it's actually also nice because it allows you to have some strategy for deploying a model. You can have like a blue-green deployment, or you can have like an A/B deployment, A/B test deployment, and yeah. So yeah, we wanted to show some code. We wanted to have some workshop, but yeah, that's how is it. Any questions? Sorry.
Yeah, so when it comes to like workflows, so from what I understand, all the workflows just kind of react to each other. So once one of them on a lower branch finishes, then the next one kind of like works. But how about like scheduling them?
That's a great question. So scheduling is actually also supported with the framework. So if we get back, yeah, if you check the documentation of the framework, so we have a very nice API that is very intuitive. So if you want to schedule like a work that runs, for example, every day or every hour or triggers on some event, you can just like if we get back here, for example, so inside the run method, you can have just very simple if condition that says every hour run this server or every hour run this training job. And yeah, awesome. Thanks.
Hello, great. Yeah, also don't forget it's just Python, import time, and just, that's it.
So this is, the scheduling is very interesting. So for me as a researcher, what I usually do is I deploy something, let it run, and then I go off and read my papers. Is there a way like to get like a notification when things are ready? For example, if there's a long-running script, like getting a ping, or I don't know, is there some way to get notified?
I believe there was like a component that it's Slack notification. So if there's like, if someone in the community built a component that sends you an email or sends you a Slack message, you can just plug and play in your app, and then you will get it just like Python.
Nice, nice. Thank you.
Hello. Yeah, there are a bunch of those right now. You can get email notifications, you can get a text message, you can get a Slack message, Telegram also apparently, and you can build your own if you want. I mean, it's a few lines of code on the app gallery, so it's great.
More questions? Right. Thanks, everyone.
Okay, we're back. Yeah, I just want to add one more thing. So there are a few apps that you've seen today, like Flashy and the video app, and they are meant to illustrate starting points for things you might want to build, right? Honestly, there are a lot of products and apps today that at the core have a flashy element to it, right? Where it's, I want to do hyperparameter sweep or something like that. We're not trying to build a hyperparameter sweep app here. It is what it is, and people can use it for that, but there are many other cool tools out there built by big companies where they do better hyperparameter sweeps, they do have better inference engines, whatever, but now they have a way to build their own versions of these apps to use those tools. So.
Hello? All right. While that's getting up, I see I know most of you here already, so my name is Eric Chia. For those who don't know me, I am a data engineer at Lightning AI, and today I'll be talking about or presenting this app, AI-powered Hacker News. And it was built collectively amongst a few folks, of which some folks couldn't join us because they're remote in India, including Kaushik Boka and Rohit. And from the design perspective, we had Regina help with that, and Mark. He kind of like wrangled spreadsheets, right? That's what your job was, to do spreadsheets. And then, yeah, so it's a pretty simple app on its face. So if you can go ahead and, for those who are interested, I won't go through the walkthrough. I mean, it's very similar. You can launch the application. You can go to the GitHub repo. You can clone and run and try it for yourself. So at this point, why don't you go ahead and click that launch gray button for me, please? Okay, so here's the UI. Once you hit this up, it's actually a Streamlit UI that's being presented here. There are some nuances about how we managed multi-user sessions. If you want to learn about that and how we manage that with our framework versus Streamlit's framework, more than happy to talk about it, but I won't go into it here. And then, you know, what it is, it's an interface that sits on top of Hacker News, and what we do is simplify and enable you to do quicker looks into what's useful for you as a user, right? So if you've favorited anything on Hacker News, what we're doing is we scrape that information and we present relevant things for you, and we create some topic classifications. So if you can, in the text box, type in Mr. Alex Clay for me. Oh, just Alex Clay, sorry. No space. And then hit enter. And the back end, there's a few things going on, but in this iteration, what we're doing is we're making a call to our Fast API server, which is an interface between that and our database. And so here, what we do is also create a set of categories for you. And if you can hit choose an option, just to demonstrate the UI a little bit, just select one of these for me, like culture and arts maybe. And it should give you a listing of culture and arts. It looked like there was a bit of a lag there. But anyhow, that's really the app, and that's what we've created here. And the orientation that we took for this application is we wanted to build it using Lightning and in a way that allows us to do ML ops, right? So there's a lot of really sophisticated parts to this, and this is our first iteration on it. So at this point, I do want to talk about the architecture a little bit. So if you can go to the Lightning AI tab right here, and scroll down, actually. We'll just use this as a benchmark. Luca and Mansi has gone over really nicely how our framework works. So from my perspective, coming in as a data engineer, I like the idea of being able to have an outside-in check on our system. So we created what's called a health check work. And what that thing is doing is looking at our system, specifically our fast API server. And when it's enabled, we then communicate that to the rest of the system to serve up the Streamlit UI. Now, if you can go to the IDE, please. So if you can start here. Yep, this is fine. So practically speaking, if you look in the run method, what's literally happening here is we do model serve.run. Model serve is literally the thing that supports the fast API server. That's the service that's running. And once our health check, which is listening for when that server is enabled, which we can write in a simple line of code there. We then go down. So if it is healthy, then we go to the else statement, and then we can run the UI. And literally like 5 lines of code, we're able to control like when a service gets stood up. Like if you were to try to do this in Terraform or any other systems, I love Terraform for what it enables, but you can imagine the power of this, right? You're just writing it strictly in Python. And this last part is also just a little bit of information about how you would, some logic in Python, whether you would render the pages as starting versus not. It's just all like front-end stuff at that point. Now, I actually didn't catch your name, the one person who asked about scheduling. Well, all right, why don't we go to the Hacker News Live tab, just right above on the IDE. Yep, cool. If you scroll up just a little bit, right there, can you stop there? Thank you. So we do natively support the concept of scheduling, which is a really nice interface. You can use cron type of scheduling. What we are showing here is an example of how you can control the flow and using scheduling as an example. So here we set self.last fetch time is the last time we reached and asked Hacker News for data, right? And what's not shown here is the time interval. And so we can set that time interval to anything you want. And by virtue of this, we set it to 5 seconds. So if the current time versus the last time we fetched is beyond 5 seconds, then we go through the rest of the code block. Otherwise, we actually don't continue, right? So that's an example of how we can control our flow. And beyond that, this might be a little bit advanced, but I think it's worth noting because it's a really cool outcome of this framework. So this framework is running on this continuous loop, right? And what we can do just by managing the variables that we pass to, so if you look at line 42, item getter.run, that will be, will only run once, right? So we can set the variables to run once, and if that parameter that we pass to it is the same, it will no longer continue to execute that run. Now, if that parameter does change, our system then understands that, hey, we would now tell that run method to run again. So by virtue of passing a different last fetch time, we're now able to tell, hey, we want you to run again, right? Without having to really manage in any sophisticated if-else logics, which is really cool about the system. And I probably won't go into any more details about this part, but if you scroll down just a little bit. Cool, right there. So, that's the top part was about how we pull data from Hacker News. And the last part is what we do with that data. And what we do with that data is we have two works, which is a topic classifier and a story encoder. And that data, with a couple lines of code, you can create topic classifications and create a story encoder, which we pass on later to our recommendation algorithm. And we've built this nice component here, which is a BigQuery component that plays nicely with our current framework. And the thinking here is that we want our users to come with their data the way they want to manage their data. And so with a BQ and other things like Snowflake and whatnot, we want to enable our users to come into our ecosystem really friendly in the way that they want to. So with the BQ inserter, you just run a couple lines of code, and that goes into the warehouse. And scroll down a little bit, please. And right, so and that's pretty much like how you can design an ETL pipeline in a fairly easy manner. Right now, what we're really curious about is, and want to invest some time into, is developing this reactive, leveraging our framework to do like real-time work, right? So you can imagine putting a message queue like PubSub or Kinesis on top of this that intervenes and plays nicely with these polling systems that we have in place. As a data engineer, I think other data teams in the world will find this like really exciting. So, well, thank you for your time, and thank you for listening. Any questions?
I have one question more generally to the component store and the app store. Is there an option to deploy that on premise if we work on proprietary stuff?
Yeah, honestly, I don't have a good answer to that question. But obviously, there's someone in the back of the room that does.
Hello, yes. Yes, you can deploy on-prem. On-prem meaning to a VPC. So on AWS, if you have a cluster there and it's VPC, you can literally put your AWS credentials and then we'll just manage things for you if your company allows that. And if not, we can do an actual on-prem deployment where all of it is fully inside the VPC as well. And we've done a few of those enterprise already at like major banks and tech companies. So all the SOC 2, all the compliance, all that stuff is right now very, very well handled, and the things that we're missing, we know as well. But unless you're literally at like one of the top 5 banks, I'm sure we got you covered. Okay, great. Then we got you covered.
Cool. Well, if there's no other questions, I'll be around during happy hour and happy to chat with you all about anything you're interested in. And go check us out on lightning.ai. There's a slew of applications there. There's a slew of components. Check them out, share them, let folks know. I'm personally very excited by this and would love the opportunity to have that spread out. So go check it out.